Hello everyone. Let us discuss about the candidate elimination algorithm in this video. So, candidate elimination learning algorithm, what it does is computes the version space containing all hypotheses from H that are consistent with an observed sequence of training examples. Whatever training examples we observe, based on that it will create an hypothesis space, a version space it will create. So what it will do is, first it will begin by initializing two boundaries. One is general boundary, another one is specific boundary. General boundary means it includes all the means it leads to a generalization of hypothesis. We call it as most general hypothesis that will accept all the values. Another one is a specific boundary. A specific boundary means it is a most specific hypothesis which contains all null values. Okay, it is least general, means it is very specific. So these two boundary sets limit the entire hypothesis space, because every other hypothesis in H is both more general than S naught and more specific than G naught. So let us see the example. Let us see the algorithm first. So as the algorithm says, there are, for the first stage here is first step. So we will have to initialize G to the set of maximally general hypothesis in H, as we have done in the previous slide. G equals to all question marks. Okay. Another one is we initialize S to the set of maximally specific hypothesis in H. Okay, that is nothing but all null values. If D is positive example, okay, whatever examples we will consider, in those examples, if the particular example what we are considering is a positive example, we will remove from G any hypothesis inconsistent with D. We will see in example how it is inconsistent or consistent. If there is any hypothesis which is inconsistent with the example what we are considering is inconsistent, then we will remove it from the general hypothesis. So for each hypothesis S in S that is not consistent with D, we will remove that S, that is hypothesis S which is specific, from the hypothesis space, most specific hypothesis space. Then we will add to S all minimal generalizations H of S such that H is consistent with D and some member of G is more general than H. Then we will remove from S any hypothesis that is more general than another hypothesis in S. So we will consider the example, then only we will understand this. So this is for positive example. If D is a negative example, what we have to do is, we have to remove from S any hypothesis which is inconsistent with D. Okay. For each hypothesis G in G that is not consistent with D, we have to remove that particular G from a set of general hypothesis. Then we have to add to G all minimal specializations H of G such that H is consistent with D. Then add and some member of S is more specific than H. Remove from G any hypothesis that is less general than another hypothesis in G. Okay, we will see the example, then we will understand it completely. Okay, so this example we are considering. We are considering the Enjoy Sport game. We have considered the Enjoy Sport game here, which have 4 examples. Let me show you the 4 examples. These are the 4 examples of Enjoy Sport game, where we have 3 positive and 1 negative example. Okay. So as there in the algorithm, first we have to initialize the specific boundary and the general boundary. This is specific boundary, that is S naught. This is specific boundary, which is all null values, most specific value. Then we have to initialize the most general hypothesis, that is all question marks, which accepts any values. Now based on these, we have to start bringing out the most specific and most general hypothesis. So that is what we have done here in the first case. So on both cases we have to consider each example, first for specific and then for general. If the example is positive one, what we have to do according to the algorithm, if D is a positive example, remove from G any hypothesis inconsistent with D. Okay. From G we have to remove any hypothesis which is inconsistent with D. See, let us consider the first example here. We have this example. Okay. If you compare this example with the general hypothesis, that is all question marks. Okay. Any value is acceptable. Question mark means any value is acceptable here. So these all values are acceptable. These all values are acceptable in the sense which will be considered as a positive example. So it is a positive example here. It is consistent. So we say that it is consistent. It is not inconsistent. Since it accepts all values, it is consistent. So G1 will become same. Let us come for this specific boundary here. So here we have all null values. So no values are acceptable. If you compare this with this one, it is inconsistent. So what we have to do for this one, we have to replace all these null values with the values which are available inside the example. Okay, since it classifies it as negative, but we want it as a positive. So we have to replace all null values with the values available in the example. So we have replaced it. That will become S1 for us. Okay. Similarly, we will go for the second example. Okay. For second example, what happens? In case of general hypothesis, again all values are acceptable here. Since there are question marks, all values are acceptable, which will classify it as a positive example. Okay. So it is consistent with this general hypothesis. So there will not be again any change. So that will become G2. Now coming back to this specific hypothesis, now we have to consider S1. S1 is compared with this example 2. Okay. So sunny is same here, warm is same. Here we have normal, but here we have high. So we say that it is inconsistent. We say that it is inconsistent. To make it consistent, we have to replace this normal with a question mark. So this is same as we have done in the find S algorithm. Okay, this part is same as find S algorithm. We have to replace this with question mark. The remaining again are same, strong, warm and same. So they will remain same. That will become S2. Now consider example 3, which is negative. Okay, there is a negative example. So there will not be any change in the specific hypothesis since it is a negative example. It will become same. S2, S3 will be same. Now coming to this general hypothesis, since it is a negative example, what we have to do is we have to compare this with this. How we have to change, how we will get these hypotheses means, whatever value we have here for all these attributes, just we have to replace them with its negative value, with its opposite value. Okay. For first attribute, we have two values, that is sunny and rainy. So we have rainy here in the example, we have to replace with sunny. Second is remaining are all question marks. Okay. Then in the second case, we have cold here, just we have to replace it with warm. So first one is question mark, remaining are all warm. Okay. Then I will tell why we have not taken high and strong here. High, strong and warm. And third one comes, we have change here. We have change here. So we have replaced it with same. Okay. Here let us see, we have considered all 5 examples. Sunny, this one is warm, then same we have taken. The third example is what? High is there, we have replaced it with normal. Then we have cool, that is fifth attribute, fourth attribute, that is cool. We have taken, sorry, this is warm, we have taken cool here. Okay. So now if we compare this with these particular three values, three examples whatever considered, first two will become consistent. But if you consider this one, it will become inconsistent. How? See the first example, first two are question mark, second one is, third one is normal, and other three are acceptable. It will be a positive one, that is classifies as positive. Now consider the second example. Here it is high, but here we have taken it as normal. Okay, here we have taken it as normal. Should be here it is classified as positive, but here it is classified as negative. Here it will be classified as negative. So this should be removed. That is what is there in the algorithm. So, similarly, consider this one. For first two, here it is, first 4 attributes are question mark, acceptable, but the fifth one is what? Here it is warm, but here it is cool. Since it is classifies it as positive, but here it will be classified as negative, so this also will be removed. Okay. Now if you consider other 3, they will be acceptable for all the three examples whatever we have considered till now. So we have to remove these 2. So after removing these 2, only these 3 will remain here. Now considering the fourth example. Considering the fourth example here. So for specific hypothesis, what we will get? Sunny, warm, high, strong and cool change are there. So we will compare this with S3 now. Sunny same, warm same, question mark is there. So question marks repeat here. Strong, here it is strong. Warm here, but here in example we have cool, so we will replace it with question mark. Then we have a same, but here it is change, so again we will replace it with question mark. So we get S4. If you consider the general boundary, G4 will be what? So Sunny, all question marks, this one. Same will be removed here. 5. So how we get the G4 is, so first when we encounter the fourth example, we will compare this with this general hypothesis which we have got these values. So we will just compare this first one, first hypothesis. Sunny is sunny, same. All the 5 question marks can be accepted here. So it is classified as positive. So this will be remain. Okay, we will retain it. If you consider the second one, first one will be replaced with question mark. Second warm matches. All other 4 are question marks. So they are acceptable. So positive classification, that is also retained. So remaining one is this one. So if you take the first 5 question marks, they are acceptable here. But the last one is same here, but it is changed. So since there is it is not a perfect match, we have to remove it. So it is removed. So that is the final one. Okay. So this is how the candidate elimination algorithm works.